Okay, so I just wanted to remind you a little bit about what we did in class today. We had a buzzer, remember that awful sound? And then we also tried swinging it around. And we noticed some differences when we did that. Now this graph is from the class today, and we talked about how these bulges, when it got tall like this, is when the buzzer was close to the probe, and then when it tapered off like this, it must be when it's not as close to the probe. So we went in and we measured this little bit of space kind of as it approached. So this was kind of, we would zoom in, we would zoom in as the buzzer approached the probe, and so you can kind of zoom in and you can continue to zoom in, and we did some counting of waves. So we did a bunch of zooming in like this, and we actually counted out 34 waves and did some math to calculate the average length of one wave. And then we looked at an area after the bulge, so that would be kind of when the buzzer was departing from the probe. And we zoomed in, and we zoomed in, and we zoomed in, and we kept zooming in, and then we counted again, found a little area patch, and again we counted 34 waves, and then divided by 34 to calculate the length of one wave. So let's check out one of the students' notebooks. Look at Melina's here, and so she got the title in, the date. She also put in a table for the tuning forks. That was another kind of piece of the experiment, mostly just to remind you about that relationship between wavelength and frequency. And then, as you can see, she's got her calculations here. So if I hit enter, you can see that when we counted out 35 waves, it was 0.010367 seconds. And you can see how she divided by 34 to get the length of one wave. Okay? Then over here, you can see that she took 1, as in 1 second, and divided it by that wavelength to figure out how many waves would fit in a second, and came up with 3,279 roughly. I'm going to take these two numbers and I'm going to round them because that'll make them a little bit easier to kind of digest. Okay? And I would like to round these two. Let's see kind of what rounding options we have. If I do custom decimals, seems like if we had 10, would that be more reasonable? It says it's working. Anyhow, so then we did the same thing with this cell here. So I'm going to click on here and enter. Oh, now it's going to say it's trying to reach Google. Ah, it's back. Okay. You can see here we did 0.010066, so that was the length of 34 waves, and we divided it by 34 to get the length of one wave. And then we did the math to get the hertz. So this, the top hertz was the wavelength as the sound was moving away from the probe, and this bottom number is the wavelength as the buzzer was moving towards the probe. And you can see that the pitch is higher as the buzzer's moving towards the probe than it is when it's moving away. So that's kind of what you're writing about in this. So I hope that helps a little bit, kind of reminding you of the numbers and what we did. Good luck doing your homework.